Hello everybody, my name is Mihir Patel. I'm a chemical engineer. Additionally, I'm a project management professional, PMP, as well as a TUV suit certified functional safety professional in engineering. Today we are going to discuss utilities, which is a specific chapter number 16 in the book. Now a utility, as all of you are aware, is a medium which is either directly used in the process or which is indirectly used and is reusable. For example, you have steam stripping, which is a direct usage of a utility in a column. Alternatively, you have cooling water systems, chilled water systems, which are reusable systems. Now, the utility requirement in a process plant is specific and custom made to that particular process. So each and every type of chemical plant may have a different configuration of utilities. For example, if you have a large refinery, you may have the whole gamut of utilities which start out with, for example, the water purification system. So you have raw water, then you have fire water, you have soft water, DM water, boiler feed water. Then you end up with compressed air, nitrogen, fuel gas systems, refrigeration, effluent systems, flare systems. Then you have the peripheral systems, which are oily water sewer systems, CBD systems, which are chemical blowdown systems. That is as far as the large petrochemical and refinery plants are concerned. Now you have let's say you have a small scale industry which is manufacturing a specialty chemical. So there you may not have this whole gamut of utilities. You will have specific utilities which is applicable to that process only. As far as utilities are concerned, the first document that is used for the design is you start out with the process simulation. So in the process simulation, process flow diagrams, heat and material balance, the requirement of utilities is identified at what approach temperatures, what are the requirements, etc. And after that you end up with the process design basis. So process design basis also gives the specification of the utilities, and then you take each system for further design. So for example, now let us cover the compressed air systems. So compressed air is specifically used for plant air systems, instrument air systems, and you have another system which is breathing air system, which is used only for very toxic chemical plants. For example, you have a chlorine plant where a breathing air system is very much required for safety of the personnel. Now when we talk about compressed air systems, so when the definition of the process flow diagram is defined, next step comes the P&ID diagram. So piping and instrumentation diagram, there you define the exact requirements of the on-off valves as well as the control valves. From this, the usage of the instrument air and plant air is now estimated, and based on that the design of that compressor system is formed up, specification in ways of the capacities, the equipments required. For example, you start out with the compressors. Mostly screw compressors are required here, oil-free stripe screw compressors, although small plants may use reciprocating compressors also. Then you have a wet air receiver, which is roughly around 3 to 5 minutes of throughput storage capacity. Then you have the air dryers. Many types of air dryers are there. So again you have to decide. If it's a small capacity, you may go with a heatless type dryer. If it is a large capacity, you may go with a HOC type dryer, heat of compression type dryer. Then you have the dryer receiver, and then finally the instrument air goes out. So like this, each and every utility system is defined and specified. Now in the chapter 16, which I have covered all these utility systems, where you will get a lot of amount of information so that it will aid you in your process engineering for utilities. Please kindly visit the website which is shown, and please use it for your benefit in your process engineering work. I thank you everybody. Thank you everybody.